Okay. For everybody in the room just now, we have don't get caught embedding.
I wouldn't say the full.
Embed. Yeah, don't get caught embed. Finding and preventing software security bugs at its lowest level with Aaron Guzman.
Thank you. Hello, everyone. It's a pretty big room here. I'm going to take a little kind of a poll and kind of gauge interest or backgrounds. So who in here has done, let's say, hardware hacking? Let's start there. Awesome. We have some people. How about, let's say, firmware reversing? Okay, so we're going to go through a lot of that. How about application security in general, mobile, web? Okay, cool. So a lot of AppSec-ish people. Okay, I'm going to go ahead and get started. So again, my name is Aaron Guzman. It's my Twitter handle. A lot of my research is around mobile, IoT, embedded as well. I've spoken at DEF CON IoT Village the last couple years, again, on IoT, and hopefully this year I have some car hacking research that I did over in back in February. Some cool stuff, so hopefully we'll see me there again. Spoke at DerbyCon as well. I was also a technical editor for Practical Internet of Things Security book. I'm also writing an IoT pen testing book right now for Packet Publishing. So sometime in the summer should be published. I'm hoping. I've also spoken at RSA. I'm also one of the organizers for AppSec California. So I'm also on the board for OWASP Los Angeles. So AppSec California is basically we have a conference on the beach last week of January. So if any of you guys, want to get away from the cold, the cloudiness, we have a ton of great speakers, like a lot of bugs, for example, like a Java serialization bug came out of our conference. A ton of great people. If you guys want to volunteer, I manage volunteers. That's a free way to get in. I'm also on the board for Cloud Security Alliance, Southern California, previous president as well. And previous employer, I used to work for Belkin and Linksys, CC League Security for Linksys. Anybody heard of Linksys before? Linksys routers? Okay, that's so. So I was managing the networking, like the routers and the cameras on the security side and infrastructure. That's kind of how I got wrapped up in the embedded and IoT type of space. Now I am working with SecureWorks. I actually have an office here in Edinburgh. Represent. Great company. Obviously, I'm here from Los Angeles, so they definitely promote community involvement. So if you guys are pen testers, great place to be. We also have, like a SOC, for example, managed services. But, to get started, jumping in, what is, embedded technology? It's kind of a broad term, there's not really a definition. SpongeBob. So embedded is routers, obviously. We have connected vehicles, cameras. It's basically small devices that have a small footprint and memory and storage as well. You have doorbells, video doorbells. Those are fun. Lights, even traffic lights, even, some cities are completely ran over, obviously, embedded technology, but even wireless as well. Parking meters, cities like San Francisco in the States, a ton of parking meters, even in Los Angeles. Medical devices, smart TVs. So this is something you guys are probably already familiar with, but just to kind of set the stage there, and kiosks as well. And of course, ICS systems, which are fun and interesting and different type of beast, but still embedded, different type of operating systems as well with that. So generally, embedded is Internet of Things, except, network connectivity is just a difference. So, not to get wrapped up in the semantics of embedded, but again, I just think of embedded as IoT, and now it's network connected over the internet. So, obviously, I'm not supposed to read all of this, but just to get an idea of the IoT landscape, so many different spaces with connected vehicles and industrial, internet, enterprise, and you have telecom, you have platforms. Obviously, everyone's writing code, everyone's touching this one piece of small device. Starts from the hardware down to the firmware, to the mobile apps, to the web applications as well. So huge space, obviously, it's only getting bigger. and it's inevitable worldwide. So don't worry about squinting. It's not, just obviously it's really, really big space. So again, I talked about kind of, how devices are being made. So like with the supply chain of IoT devices, you have a PCB, hardware design from the beginning. You want to map out your peripherals and also have your BSP. So that's usually someone like Broadcom, the device driver makers to connect the hardware and software. Broadcom or Marvell, even with like say your Wi-Fi chips in your PCs, usually you'll say like Marvell, for example. They're also pretty common. I think even Broadcom, there was a zero-day research from Google, I think last week, on SLC for Broadcom, basically remote code execution. So that's kind of where it stems from. Driver makers, BSP. So you have to choose who supports the peripherals your device is going to be featured. You have ODMs. ODM is basically the biggest problem in embedded and IoT space. And I say usually from Taiwan because they're usually from Taiwan. I was in several different calls for product design with Linksys, and you're speaking to companies, 10 to 15. 5 or 6 of them are project managers. You have 3 different developers who write, either front UI and then some C, C++. But whenever you hear of bugs like from D-Link, Netgear, even Balkan, they're all affected for this one type of firmware or bug, for example. It's because you're using the same ODM. They have the right to repackage that software and distribute it out to any other third party that the OEM will support here. So to back up a bit, the cloud, you also have a cloud service provider who provides, remote access, for example. So it's usually like the Amazons, the Azures, not really DigitalOcean, but those are usually the most common. Even connected vehicles, the connected vehicles I have tested, they're usually running off of Amazon, which is pretty interesting. So again, the OEM supports basically the whole supply chain from beginning to end. Even if there's an issue with the ODM. Now the ODM, like I said, it's a small team, so they're also a dime a dozen, meaning that the cheapest ODM who's able to supply code for the OEM is going to win because the margin is so small on these devices to make money. And the OEM, okay, so say that there is a bug that gets published on a 10-year-old camera, but the ODM is no longer in business. Usually what the ODM does is supply a binary over to the OEM, and it just has to pass a number of unit tests in order for the OEM to accept it. And now the ODM isn't in business, so who's going to fix it? There's no sunsetting rules for, let's say, consumer devices, but even for commercial devices as well. So it's kind of crucial here is the ODM, the guy in the middle, who's providing much of the code that the OEM is supporting and just building upon. So an OEM could be Nest, it could be a number of different other manufacturers. But again, just the embedded or IoT type of supply chain is just kind of how it looks. And just from my experience, again, I think this guy is a key player. And he's the one, or he or she is the one who's causing a lot of issues that you see on the internet, is from the ODM side. So what these devices commonly run on, embedded Linux is probably the most common for non-commercial devices. Some of them are even based off of Android and really old kernels. I still see new products being deployed with 2.6 kernels when we're up to like 3.4 or something, 6, something like that. Even with Android, I also saw a Kickstarter. It was supposed to be an IoT security device that has Android 4.4 running, which is ancient. You have real-time operating system, RTOS. Those are usually licensed and commercial, so you have VxWorks and MQX and Green Hills. You have Windows Embedded. I'm obviously not a Windows guy. Windows IoT Core. These two are not so common here. So just to discuss, a little bit of what happened in 2016. Obviously, more and more medical device research and more insulin pumps and even basically sensors that are being triggered in everybody's body to kind of collect metadata. You have a lot of clear text communications. You have consulting pen testing companies who are doing this research, to basically analyze the state of the medical field, whether in hospitals or devices themselves. You have consumer, ton of backdoors, hard-coded credentials, command injection everywhere, definitely. And this is how people, I think one of the speakers here later on today, one of the keynotes, I think he presented at DEF CON IoT Village where based off of command injection, they were able to upload their own firmware and then provide ransomware to a thermostat, which is pretty cool. But that's what you can do. That's the power of command injection. Mirai, have you guys heard of Mirai? Yeah, basically took down our country. Connected vehicles. Connected vehicle research, obviously a ton. You have Tesla. I spoke a little bit about my research, but there's a ton. Obviously year after year, it's going to get more and more common. You have them in bug bounty programs with, BugCrowd, for example. Commercial cameras and ransomware as well. Even with the hotels, you guys heard about the hotel where everyone got locked in their rooms. That was pretty funny. ICS systems, same thing. There's always, if you look at ICS alerts, Google ICS alerts or advisories, there's ton. It's all the same examples of clear text communications for CVEs that get published, as well as backdoors, not router backdoors, but just general backdoors, meaning hard-coded credentials, and even accounts that can be used to bypass authentication. So again, hard-coded passwords. So again, Mirai was huge, like I said. It basically took down our East Coast. Good thing we live in the West Coast. But yeah, so basically, DDoSed, dying DNS. But again, it was pretty huge. I think it was over a terabyte. It was said to be over a terabyte, the biggest DDoS in history. It's only going to get bigger. And these were all, obviously taking advantage from insecure coding of devices for cameras and routers. Basically, consumer devices were taken advantage of, and settings were changed, and it was able to, obviously overload dying servers. So, I mean, think about how, that's, obviously the biggest DDoS, but I think the scale of it is going to be, it's going to continue to grow, but also, a new type of attack, let's say ransomware now for these devices. I can only imagine, a lot of these mom and pop places that have cameras installed, they have installers put it in, and they don't know, the IP address, they don't know how to upload the firmware, change the firmware, whatever it may be. Now they're unlocked, and even, there's a couple recordings of the so-called attackers who created Mirai, that whenever they would lose a connection from a device, let's say someone reset their router, or they reset their cameras, they would just rerun their script and add more nodes. Simple as that. But ransomware would probably be a different situation. It's going to be interesting even with a connected car type of environment. You don't have to be locked out of your car, but say something comes up in your infotainment system that, you're driving, on the highway or whatever it may be, and, it says, pay, however much money, or your car is going to break and stop. I'm pretty sure I'll stop, even though I don't know what's going on, but still kind of different methodology or type of perspective with embedded devices and IoT in general. It's the 400-pound hackers who are doing this, from Mirai. I don't know if you guys heard about, won't get into it if you don't know it. This is the attackers from Mirai whenever they rerun the script. Get more nodes. It's DJ Khaled, by the way. So emerging technology, the stuff that's interesting in this space, I already talked about the things you guys already know. But what is emerging technology? Humans, nanotechnology is what we're going to talk about. Carbon-based nanotechnology, little small, nanometer, size of a fiber type of embedded devices. Not device, but I mean it's still a product, size of a hair. I think in February is when MIT released research where they're actually able to upload code and has input and output to run this code. And again, it's carbon fiber, so it's durable and strong. It's basically created to collect data for long periods of time for patients and monitoring. And this is a language, it's called Verilog. It's an HDL type of language, but they have web applications to automate the code based off DNA sequences. So, and they call it the language of cells. It's also a standard. I forgot which standard. Might have it here. IEEE 1364, 2005. So it's been around. It's been around since the 90s even. But this is the official standard in 2005. So attacking humans, right? That's pretty, obviously even IoT, that's kind of the new, you're bridging technology and human safety and lives, but, nanotechnology, obviously, you can probably cause some, some more damage, even if you're collecting data, but what about injecting? So again, it says it's literally a programming language for bacteria, is what Verilog is. This is a professor from MIT. Text-based language, just like you're programming a computer. Then you take the text and you compile it, turn it to a DNA sequence, and you put it into a cell, and the circuit runs inside the cell. Crazy, right? So previously, it would take years to build these types of circuits. Now you just hit the button and immediately get a DNA sequence to test. So that got me on a little rabbit hole for a while. And I found basically the little web app that they use for Verilog. And it's almost like a C-looking type of programming language, but I created a test account here and just put in random, I don't know, I'm not a biologist, I don't know DNA sequences, but I was just kind of throwing things in there. And this is what it output here. But obviously you have to have some sort of nano, hardware to load that firmware on in order for it to run. But again, obviously this is going to be the platform that they're going to be using to, again, upload the firmware, have the code run in someone's body. And just by, probably injecting something in the web application, it might cause some severe, deaths, is what I'm thinking. So here it is. Tiny fibers open new windows into the brain. 3-in-1 design allows genetic, chemical, optical, and electrical inputs and outputs. That was February 21st, I believe, this past February. So it's being used. They're testing it right now. But that's kind of the new type of targets and things that we're going to continue to see as far as embedded technology and even network connectivity even. So this is just kind of the usage of it, make it possible to leave implants in place and have them retain their functions over much longer periods than currently possible with typical stiff metallic fibers, enabling more extensive data collection is kind of what I've paraphrased earlier. So kind of taking a different approach and, how can we secure, these type of embedded devices, not with Verilog language, but specifically what I'm going to focus on is embedded Linux, since it's mostly common in what you see in, firmware and drones, things like that, consumer-wise. So some of the best practices are buffer and stack overflow protection, injection protection, so it could be command injection, it could be cross-site scripting, for example, still very alive and well. Firmware updates and cryptographic signatures, medical devices should be using this, and even drones. I think there's certain regulations to not fly within airport ranges to be able to repackage firmware and upload that to bypass those controls. If you cryptographically sign and verify, that wouldn't be possible. Securing sensitive information, identity management, hardening of the framework and your C-based tool chain. Also, the usage of debugging code and interfaces. So that could be hardware as well as backdoors. And we're going to go through each of these right now. TLS, so communication from the application or the embedded device, and usage of data collection and storage, privacy, and third-party code and components. So this is based off of some research, a research project that I lead for OWASP called the Embedded Application Security Project. And we just released version 1, and now, it's based off of embedded Linux, but The next version is going to iterate with RTOS and also Windows IoT or Windows Embedded. So if any of you guys have any expertise in those areas, please, the more people, the better to view these best practices. We want manufacturers to see them. We want people to be aware. And there's practical examples, basically non-compliant and compliant examples of what causes, we'll go through them in a second, but what causes command injection, what's a good example, what's a bad example. Usually now you'll have, for example, like there's plenty of research and guidance documents on how to reverse engineer or attack these devices, their firmware, but there's not much on how a developer can really protect from these in their language. They get handed a PDF of, hey, here's how to prevent command injection with words. They want to see code examples, so that was kind of what I aimed to do. And that's the link to the GitHub, a Gitbook of the best practices. So buffer and stack overflow protection, prevent usage of dangerous C functions. Just an example, a basic, if you have the code in front of you, if you're working for a manufacturer, a basic find and grep for some of the vulnerable functions is just there's a whole list of them which you can also search for, but it's just an example you can use. You can use safe equivalent functions for known vulnerable functions. Wow, that sounds really weird. So yeah, so there are equivalents to where some of these stir copy, stir length. You can use alternatives. Also check the bounds of the buffer, for example. Here are some of them. Gets, fgets is one example. There's loads of them. Ensure that the compiler has the correct flags for like stack protection. And sometimes even the build system for these devices can automatically input these compiler flags. So again, stack protection, with buildroot and Yocto, you can do this. Literally a menu that you can select stack protection to enable when building your firmware. Here's an example. That's all it is, and why don't manufacturers do that? It's pretty simple. There's obviously a ton of other things you can enable, but to enable stack protection, again, pretty straightforward. You don't have to do much. Again, this is with buildroot here, which is free. A lot of people have used this for their firmware. This is for stereocopy. Take a glance at that. I respect myself. That's why I refuse to use sprintf, and use sprintf as a decision you can never take back. That's why I'm waiting till I'm older, and there's a string handling function that's right for me. So injection prevention. You can whitelist accepted commands. You can also map them. Map commands, accepted commands to, let's say, numbering format, number to command. I've seen that. It's usually pretty successful as well. Or you can completely avoid user data and system commands as well, dynamic system commands. And again, in embedded, it's so easy to kind of use shell commands. Usually they have, ZSH, SH, and a few other different shells you can use, but people obviously go to system just to make things easier. Just like a lot of people maybe here use bash instead of using some other language. That's you can use on any other platform, for example. Validate user input. That's obviously huge. Context output encode characters. So whether it's hitting the system or it's replying back to or responding back to the user interface, the web. So encoding, output encoding HTML, output encoding JavaScript, or any type of other characters, let's say for the system is trying to, execute some sort of shell command. And again, command injections are really, really huge. One thing I forgot to mention is I'm working with FTC over in the States, the attorney of FTC, on using this guidance document for negligent manufacturers, and trying to get that over here to see, because again, right now there's not really much guidance to point, here's a clear guidance on how, to prevent some, command injections. And obviously this is just a snippet. There's a lot more, let's say within the Gitbook, but obviously getting some support from FTC which is pretty huge. So here's just a basic example of C, a vulnerable C example. Initializing the buffer, getting some input in the buffer size, and you have any command and the command from the interpreter, %s. And again, validating, handle the error. But obviously you have a system command here that's auto-executing this any command without any validation. It doesn't handle any errors good or safely. Then you're just adding the user's simple semicolon there as if you're in the shell. So that's not cool. Depending on what type of device it is, it could be, the impact and the safety that it can cause on the user could be larger than, let's say, a light bulb. If it's a medical device, obviously the severity is much higher. But again, just basic principles, stuff that's been around. Nothing's really new as far as how to prevent some of these bugs. They've been around for, since the beginning of time, 90s, 80s, since, C was born. Stepping along over to firmware updates. Obviously, update over TLS. Schedule updates for like medical devices. You don't want to, do a reboot when someone's walking, their pacemaker, for example. But other devices that aren't critical for functioning, let's say anything within a home, you could auto-update. And again, I talked about medical devices. And even force update in certain severity cases when they're high or critical. And implement some sort of anti-downgrade function that won't let you use previously vulnerable firmware. And that's just by validating, cryptographically signing the firmware images. So you can just sign and basically invalidate older firmware images and even encrypt those in some sort of archive and require a password. That's what I've seen. I think D-Link does that now. It won't let you install older firmware. I tried to for one of the demos here. I was like, let me get this, look for a CVE and look for a backdoor demo. But now they require a password, which is interesting. And some other vendors do that as well, not just D-Link. And again, change logs that include whatever security fixes that were made, usually security improvements, very overview-ish in the change logs. But these are also within the buildroot, for example, the build systems. They have already predetermined packages that they pull from the repositories, not that you have to download manually. So those that drop-down menu there, the menu configuration. So again, they have their own packages within their repository, so they can have older versions, let's say, of UPnP, for example. There's vulnerable versions of UPnP, loads of them actually. And if you don't check the changelog of what version that buildroot has, obviously your device is going to be vulnerable, but UPnP in general is already vulnerable, but as an example. And here's just a snippet from our documentation on how to verify, let's say, a kernel. Obviously, there's some sort of infrastructure involved in order for you to have GPG, but obvious things are not storing the private key on the device. This we learned at Belkin when I was there. That was fun. But yeah, so when you're downloading, when you're verifying GPG, you have to, it's called Web of Trust, validate, out of band, for example, when you're grabbing the keys. But basic wget of the kernels, again, this is just a basic example, but validating that the kernel image is, the integrity is still intact. And again, just decompressing and verifying the signature here. There's many different ways to do it, but again, it requires a little bit of infrastructure and some people to understand, what GPG is, and how to verify and validate. Because again, it's done wrong, and there's not much documentation on it. And we have different examples in our guidance document on how to do it. And we're looking for more, so if anybody has other feedback, we're definitely looking for contributors all the time. Securing sensitive information, hard-coding anything, really, any type of secret, passwords, tokens, personal identifiable information. Very, very common, unfortunately. And if you do have, or storing that within your file system, typically right now I know embedded devices use like SQLite databases to store this this type of information. I know routers do, from my experience. Store them in some sort of, if the device has the capability of a security element or a trusted execution environment, if it's based off of ARM, definitely viable. And do not store secrets in unprotected storage locations, like an EEPROM, for example, flash storage, SD card. There are devices that have SD cards, readable and writable. And with EEPROMs, you can just stick a SOIC clip on top, pull the firmware and pull whatever running, and you can see any type of secret that's there. And even if it's in a different partition that the file system's on, you can still pull it. So if you think that an attacker, or you think that you can hold a secret in a different partition that's outside of the firmware, and it will be safe, it's not. You can still pull it. And again, EEPROM and flash. That's kind of common sense, you would think. But a lot of these guys who write C, C++, and who are writing for these embedded devices manufacturers, they've been writing code for 10, 15 years, and they've never used web technologies and frameworks that we currently have that already auto-escape and prevent these type of issues, and even have other libraries. Everything's kind of manual, and you have to think about it. But still, again, it has to start in the requirement phase of building a device. But it seems common sense, right? Here's an example of D-Link, having a hard-coded, let's say, backdoor. Every time you send a user agent with the string here, you bypass authentication and get access to the device. So that's awful, right? And just recently, the FTC kind of pinpointed, ASUS last year, and also D-Link for basically advertising, easy to secure, advanced security, and everything's over HTTP. They're storing data in clear text. When there's things like even for their Android apps, they were storing credentials within a shared file, shared preferences, an XML file, clear text, and you can use a key store. For example, but for us over in the States, this is kind of huge. This is the first time regulations got involved in that kind of capacity for basically the impact of safety for consumers. Again, hard-coded login credentials, and the password was guessed, and it was enabled by default. So insecure defaults is what they got slapped in the hand for, but they also got charged and fined a lot of money. And same thing with ASUS. I think they have to go under 20 years of having pen tests, and I have to show that. So that's pretty interesting. So identity management over TLS. And notice I'm not saying SSL. There's no secure way to do SSL. If you can, move everything up to TLS. And even if you're moving over to iOS, the embedded device uses iOS. iOS is pushing all apps to use TLS 1.2 with app transport security. Just so you guys are kind of aware. You have to manually disable that in your app's configuration file. The info.plist is what it is. So separate accounts for internal web management, console access, remote web management, remote console access. The session IDs you usually see in the URLs. That's awful. You should see them as a header. Cookies as well. And if you could, obviously just a string that you input for the browser. Input secure flags if it's over HTTPS, hopefully, HTTP only flags. And randomize and invalidate the session IDs and cookies upon logout. So many times in these devices that I see that tokens or cookies are not expired, either on the device side or on the server side if they're ran from a manufacturer. So token reuse is kind of a term that's thrown around. Password policies, password 123. Admin is pretty common, admin password. So we're trying to push manufacturers to go this route rather than not. I've had so many arguments with management over when I was over at Linksys to try to push. They can do this for WPA2, right? WPA2 PSKs, pre-shared keys, but they can't do it with username and passwords. And it was only because of deployment script that they have to validate for production is the reason why. They had to change the process. And it's going to take changing processes. But again, this is what we're looking for and trying to push manufacturers to do. And then add input to add complex passwords to the EEPROM and JTAG. So the hardware interfaces that get access to the console. And sometimes you will come across UART passwords, but usually, again, they're password 123 or they're in the user manual. So what's the use of that? To go through framework hardening, don't use things like Telnet, SSH, remove unused languages, interpreters, Python. Lua is pretty common. Ruby I've seen in some devices. It's because it's a development version, they think, but they push it to production without realizing, and they have different interpreters, so obviously the attack surface is that much bigger. Remove dead code from unused libraries. Usually for firmware, the developers will try to minimize as much code as possible because the footprint is small. But if it's larger than what they would normally put firmware-wise or what they have available, they get messy. And then they leave vulnerable libraries or code that they're not using. But again, obviously that expands the attack surface. And I talked about shell interpreters, the different ones that are available. Remove what's not being used. Legacy daemons, Telnet, FTP, TFTP. And I say iterative threat models. I think this is very important for hardening of frameworks and operating systems because if you don't know all the libraries that are being used, all the code that's ran, and all the possible threats and impact, then how are you going to properly secure it or even test it, for example, from the attacker perspective? And again, here's the example for buildroot, how to enable the different shell environments. You have bash, dash, and ZSH. There's more depending on the different version of buildroot. The other screenshot I have was 2016. This is 2015. But different versions of buildroot, they have different options. And again, simple. Same thing with FTP. It's all just a drop down. And it auto builds it for you for your firmware. See, this one's 2016. So, usage of debugging code. This is backdoor code with root privileges. We talked about the user agent header. And usually their excuse is we use it for customer support. We need to get access to change whatever services for grandpa, for example. And again, debugging for developers. They need to get access to a real production device. And they hard code this into the firmware image. That's the excuses I've heard in that field. And they think it's justifiable from a product perspective. But for us, security-oriented minds, obviously, it's a red flag, and it's you would think it's common sense, but different type of beasts, different people in that field. They think the firewall's still going to protect you. But anyways, third-party libraries, SDKs, and binary images need review. Like I was saying, ODMs basically pass over binary images and files and libraries over to the manufacturers, the OEMs. I think there was a big USB, net USB, I believe it was called. That was a third party, and every SMB and USB capability and routers, for example, that's another third party firm who's creating that code and passing it over to an OEM. So not only do you have an ODM, you have this other third-party company who's providing, let's say, like Twonky media services, for example. And then, like I said, the USB, the net USB, that's a different provider all in itself. And binary code, they're giving it to them. Not necessarily, they don't have the source code. But they need to be reviewed. And there's new products that are coming out. I'm not going to name drop the companies, but that can basically auto-reverse engineer and extract the file systems to review these type of binary files, and implement some sort of liability and service agreement into between the OEM and the ODM. Make them liable for whatever type of security incident. Make them have someone on staff that has some security expertise and knowledge, security certification, just a baseline, something to kind of point the finger in a way. And any other third party as well. And this is something that we did over at Belkin and Linksys as well. So trying to push that type of culture, make someone liable, because if there's a bug, it's a big gray area. But if you incorporate that into your new product and service agreement, then obviously someone's held liable and they sign it. And again, super common to have these backdoors, and all because of the ODMs, is what I'm thinking. Is what I see, actually, in the wild. And this is usually what they say when they do their unit test. That's Stevie Wonder, he's blind, so. So let me take a step back. I only have like 15 minutes here, and give an example of how easy it is to basically look through an image, a binary image, not a binary image, a firmware image, using something like binwalk. Have you guys heard of binwalk before? A few people? Okay. It basically extracts the file system for you. It looks kind of weird. Let's broaden that out. So where I'm at, I'm using ZSH here. I'm in a firmwares directory, and obviously, I research a lot of firmware. So we have D-Link, we have a couple Linksys router firmware images, and I already extracted them. The one with underscores are already extracted file systems. And all I did was binwalk-e and the firmware image, and it auto-extracted it. Pretty simple. Not every firmware image is going to be like that. But what I do, so I'm already in WRT 1200 AC, the router firmware, and I extracted the file system with binwalk, and now I'm in the file system. Usually what I do is grep for passwords, different kinds of passwords and keys. I'll list it out, first thing. And what I already know, I just found this out earlier this morning. I usually look through the configuration files, but you also see like comments and funny things going on, like to-dos. But one thing I found was a password. And I was like, hey, what's that password? So let's go take a look here. I don't know where that was at. Oops. So I guess this is where it uses, this is the shell command that it uses, that password here. Didn't know that, just saw that right now. Again, I saw this morning. Etsy system defaults. Demo fail, where are we at? Oh, I backed up into the wrong one. Here, let's go into another one. Because I also found it in a different firmware image. Now that I know where it's at. CD Etsy. System. So here it is. Looks like they use Amazon. Looks like there's a user. And I was actually able to log in. But the thing is with Amazon, I'm still working with this. You have to whitelist accepted emails. So I found one, and I was trying to make it look like I was coming from Linksys to send email out to somebody. So I'm working on that. Obviously, I just found that this morning. But it's in a couple of their firmware images. We can also do the same thing. This is a D-Link firmware image. But again, pretty simple. It's almost like, you could even understand the function of what's being used. Obviously, you have, raw queries, for example. You can check that out different ways. Different ways it's used and it's stored dynamically as well. But pretty simple, like I said. binwalk kind of does the heavy lifting for you. And there's more examples in here, but in the interest of time, we have 10 minutes. Whoa. Can I present? Excuse me, Steve, I wonder. All right, cool. All right, so TLS, I was talking about using 1.2 or high as possible. Validate the public key, host name, and certificate chain. This is hardly ever done, especially in embedded devices. Commercial devices, a little bit. Even deploy your own cert. Ensure you're using a new, hashing algorithm for signing. If you use SHA-1, MD5, very, very old. Disable deprecated SSL versions in all of them if you can. And TLS 1.2, certain cipher suites are vulnerable to client-side attacks, not too high in severity. And then weak ciphers as well, or null ciphers, disable those. And then in case or when the certificate does expire, make sure there's some sort of way, a function or a mechanism that you can update that certificate. There's examples like a manufacturer where it was a hub, IoT hub, where the certificate expired and they got locked out of all their products inside their house and they had to ship back the device back to the manufacturer to update the certificate. It's pretty awful. Yeah, so that really has happened. And simple things to verify. You can use Nmap. You can use different Nmap scripts, SSL scan, SSLize, test SSL server, or if it's public, SSL labs.
Just to note that test SSL server, this is the old version in Java, which I don't maintain anymore, and there's a new one in C# which does a lot more things.
Oh, awesome. Glad I put it in there. So there's a new one out there, C#. Cool, thank you. Yeah, just look at that. It's kind of the way I feel. And obviously, if you guys have never used Nmap, but this is an example from one test device I have using SHA-1 and some vulnerable, SSL v3 vulnerable inherently. And there's also some vulnerable, triple DES, RC4 vulnerable cipher suites. Data collection and storage, privacy by design is kind of what we're looking for, which is acquire the least data as you can for operational functions. So don't acquire it if you don't need it. Transparency, making sure that the users are aware how that data is being stored. I know, over here in the EU is a little bit different as far as the requirements, but even so, I know the same manufacturers who sell in the States and sell over here, they're not abiding by certain privacy regulations by even being transparent about them. And then allow the device owner to reset their personal data and have the ability to basically erase it, which again is not being incorporated by a lot of manufacturers. But who is doing it? People like Androids and iPhones are doing this. I go in occasionally and just reset my advertising identifier, to basically switch up that unique ID. And again, Android has the same function, but just as an example, who's doing things like this. So third-party code and components. We already discussed a little bit of the ODM side, but bill of materials, check against vulnerable databases. And then there's tons of free tools to help with libraries from the framework aspect. Front end, you have Retire.js, lib scanner for Yocto. You could build into your build system. You can also build it into a continuous integration. Most of these have the ability to plug into a continuous integration environment. And most of these manufacturers are in a CI environment. You can use NSP for Node.js, Linus. I don't know if you guys heard that's a free tool for hardening, and also checks for different kernel versions, and if CVEs are published for different libraries and kernels as well. And then for dynamic testing, say for web or mobile, you can use something like OWASP Zap, use the REST API to scan every build. Again, in a CI environment, they're very easy to kick off. It's like sequential steps. And then again, review changelogs of tool chains, software packages, and libraries, and we talked about that with buildroot and Yocto. And then if possible, because you can also utilize package managers. That's the thing with firmware. Usually when there's a vulnerable library, people think you have to reflash the whole firmware image. But you can also use package managers to update it. But again, it takes some testing. And they have the ability within Yocto and buildroot to do that. And I know if you guys have used like Wi-Fi Pineapple, anybody use Wi-Fi Pineapple? Yeah, they use, I think they use OPKG, both of these, right? I think they use both of them. And again, it's the same type of device. You can do that, and run certain scripts from the manufacturer side. And you don't necessarily have to, depending on what library is being used or what needs to be updated, you have to reflash the whole firmware. You can use a package manager. So again, rinse and repeat each of these from buffer overflow prevention to command injection, all the way down to the third-party components here, and review. So continuous threat models is key from the embedded side, the mobile side, the web side, infrastructure side as well. Continuous testing, update as much as possible if you can for any of these devices from the consumer aspect and even from manufacturer. Auto update if you can, have some sort of feature where you check a box. Because certain regulations require the user to be aware that their device is being updated with their consent. And have a disclosure policy, get involved in the community, some sort of third-party collaboration. You can use platforms like BugCrowd to know, like, hey, we care. I think Netgear is one of them. They're doing pretty well as far as being open to the community. And some closing thoughts. Let's keep breaking things. I know me, I love getting devices and then reversing them. And for us over in the States, we had some good news back in October that security research for us, and it might be similar here, I'm not sure. I know you guys have a copyright regulation as well. But this exempts security research for consumer devices if you have rightfully owned the device, like purchased the device, and also use it with goodwill. So you're not trying to hurt people with it, with your research. I think it says lawfully acquired here. Good faith security research. It must be conducted in a controlled setting, avoid to harm individuals and the public. It's like car research. Do it in your garage or park or something. That's what I did. But that's good news for us. Anybody too. And again, let's just keep breaking things like this guy. Looks pretty happy, right? And that's it. Are there any last questions? We have a few minutes. No questions, not one? Okay, well, thank you guys. Take care.